Hey everyone, I'm a small lizard, and basically from this video onwards, we'll be looking at examples or part of examples of PnC questions, where we're going to be looking at the combination of techniques or a more complicated application of a particular technique. And as such, it's going to be like Intel Minds video, and therefore, you can pause the video right now and try to solve this question. Otherwise, here we go. It's a group of 8 people, including a family of 4 consisting of 2 parents and their 2 children. They sit in a row of 8 chairs, so a row. 2 children are seated between their parents. So because 2 children are sitting between their parents, we can draw this for illustration, PCCP. And you notice that they have to sit together, so which then makes them as one group. So we have one group of this family and then 4 remaining people for a total of 5 elements. So we start off with 5 factorial. Now, don't forget we need to arrange the elements within the subgroup. So we have PCCP. We cannot do 4 factorial because that will include cases where the 2 children are not between the 2 parents, right? PPCC, for example. Because of that, what we should do is to arrange the parents individually and children individually for 2 factorial times 2 factorial. Alright, for a total case of 480. Now, why is it 480? Because we realize there's only one way to arrange PCCP, right? There's no other way. So times 1. Alright. Now you notice in some other examples, you realize that there'll be more than one way possible. And I'll go through that in the next video. So 5 factorial times 2 factorial times 2 factorial, 480, 120 times 4. B. They went out for dinner and is assigned to a round table. So clue is round table, and you have 10 seats instead of 8, so there are extra seats. Furthermore, each child must pair up with one of the parents. Parent-child therefore sits together, otherwise pairing is for nothing. Find the number of ways they can be seated around the table with the 2 remaining seats empty. Alright, so first thing first, the 2 extra seats, which are the same. Because they are the same, you need to put yourself the reminder to divide by 2 factorial. And then the 4 remaining people, and then the 2 pairs of parent-child, for a total of 8 items. Because you want to arrange them in a round table, therefore you start off with 8 minus 1 whole thing factorial, 7 factorial. From here, you need to consider how many ways we can make this parent-child, because it could be parent 1, child 1, and then otherwise it's parent 1, child 2. Then likewise, correspondingly, parent 2, child 2, parent 2, child 1. So there are only 2 ways to arrange this PCPC. So times 2, alright? Don't forget to divide by the 2 factorial because of the same number of chairs, so we forgot about that. So yeah, that's something to take note of as well. Alright, so it's good to write it down in case you start to forget like me. So divide by 2 factorial because of 2 same seats, times 2 because there are 2 ways to make the parent-child. Now, we only found a way to make the parent-child. We haven't found a way to arrange the parent-child yet. So arrange the individual groups. 2 factorial. This then gives us 20160. You can either do 4 times 7 factorial or 8 factorial divided by 2. Alright, they will be the same. Alright, so 20160 is the answer. Are there any other ways for part B to be done? Alright, so for part B, this method of figuring out what are the available items and then arranging them in a circle. So it's kind of a step up of the normal arrangement that we have done. And in this case of extra seats as well that we need to consider as part of the additional items or part of the total number of items. Are there any other way? And the answer is yes. Alright, you could actually slot the extra chairs in at a later time. What do I mean? So what you could do first is, instead of looking at the 2 extra chairs first, we can look at arranging these 6 groups first in a circle. So 6 groups in a circle, so 5 factorial. Then 2 ways to make the PC pairs, then 2 factorial times 2 factorial to arrange each PC pair. Then you notice that when we arrange the 6 items, the 2 chairs must be over here, right? So the first chair can be put in 6 slots. The second chair can be put in 7 slots afterwards, right? So let's say you imagine we have the first chair and then 6 additional people. So notice that there are 1, 2, 3, 4, 5, 6, 7 slots to put a second chair. And because the two chairs are the same, the order in which they put in doesn't matter. So we need to divide by 2 because we put it in order, right? We put chair 1 then chair 2, where in fact it doesn't matter, so we need to divide by 2. And we notice that this gives us the same answer. 7 factorial over 2 factorial times 2 factorial times 2 factorial times 2. Alright? And it gives us back to 20160. Are there any other ways? As definitely, alright? I'm not going to go through that right now because the other idea is basically, well, you guys can give it a shot. 8 choose 6 divided by 8 times 6 factorial, if I'm not mistaken, times 2 times 2 times 2. I think something along those lines. Let me just do a quick check. So 8 choose, I don't explain the logic right now. Yeah, alright, so that is correct, yeah. Alright, so you guys can go figure out what is this idea right here. You can take it as a challenge. But otherwise, I'll see you guys in the next example in the next video.